Hello sir, I am Sujit Reddy. This is Shashank Reddy. Now we are going to explain about flood frequency analysis by Logpearson type 3 probability distribution by log linear curve fitting. Also we'll explain this in manually and also by MATLAB. This is the most popular method used by many civil engineers in modern era. Coming to the contents, we'll briefly introduce about what log Pearson distribution is and later how the data is collected for this procedure with the help of many datasets. After discussing it how to solve manually, we'll come to the MATLAB code and its execution and different types of plots and outputs. And coming to the introduction, flood frequency analysis is one of the most commonly used techniques by many hydrologists and hydrologic engineers to estimate the recurrence interval of peak discharge for a given site, and it is displayed as a flood frequency curve. It is nothing but the rainfall in coming years can be estimated easily by this method. It is also a part of advanced statistical methods which are being used. The flood frequency analysis has been used in design of hydraulic structures. Hydrologists and mathematicians such as Srikanth and McMahon examined that rock Pearson type 3 is the best fit probability model for flood-prone bases. We'll be discussing about United States data of the year 1937 to 2014 for now, which with the help of 77 data points for 77 years. Annual maximum series data which has been collected from American Meteorological Society for analysis of magnitude and frequency of floods is recorded the length of sites between 1937 to 2014. For this, the mean rainfall and the standard deviation and skewness coefficient is to be calculated before. Therefore, annual maximum discharge data has been analyzed by applying basic statistical techniques. Besides, time series graphs of annual peak discharges is also been calculated apart from the recurrence period of the rainfall. The expected design flood discharges have also been calculated for the return periods of 20 years, 40 years, 60 years, and so on. Also, the 95% confidence means that nothing but the 95% percentile has been placed on frequency curves. This is the equation which is used to calculate the final recurrence period of the rainfall. Here, Qt is the log of the discharge of required period and log Q is the mean of log annual mean series. Before explaining it in MATLAB, we'll briefly introduce it how to solve manually. The log Pearson type distribution is calculated by using yt is equals to y bar plus kt into sy, where y is the log of the discharge values and kt is the skewness coefficient which has to be calculated, and sy is nothing but root of y minus y bar whole square by n minus 1, which we have used in many formulas. And finally, the skewness coefficient is calculated by the help of this formula where Cs is equals to n into sigma ya minus y bar whole cube by n minus 1 into n minus 2 into sy cube. After finding out the Cs, the value of Kt is interpolated from this table, which was extracted by US Water Councils. After finding Kt, we can easily find out the Yt value. For now, let us discuss with the help of this example. Here, the year and the discharge has been mentioned. On the discharge, we can calculate the y value, which is nothing but log q. Now, after finding the log, all the log values of the discharge, y bar is to be calculated and sy has to be calculated. Next, kt can be calculated by using this formula, and later the kt has to be interpolated by using this table by normal linear interpolation. After obtaining the kt value, the yt can be obtained by substituting all the values. Since it is a log function, we have to raise it to the power of 10 to obtain the actual discharge. Therefore, here we got that the for 50 return period, the discharge was estimated to be 90,570 cubic feet per second. This is done this is done manually. Coming to the MATLAB code execution, we have taken some values here. Here the year has been mentioned and the discharge has been mentioned. This is taken from 1937 to 2014. Here a total number of 77 datasets has been taken, and this is the MATLAB code. Here this is the first step where the data has been taken from nothing but load from data points.txt. Load is nothing but it takes the values on the notepad. This is the notepad from which the MATLAB has taken the data. We can also add more number of data points and also change these values. And various functions have been applied here, such as dream-zs, where the number of years have been taken into the consideration. And also so many functions such as prior, draw, post, density have also been taken. Here, apart from calculating the return period, so many values have been determined, which we'll come to know while plotting it. Here are the several other functions which are included in this code. And this is the LP3 inverse function from which the KT, nothing but this is a formula which has been discussed before. And also XP is nothing but mu plus sigma k bar, which is nothing but the KT value and also the final YT value. Since we have also used many functions such as plotting functions, we'll get to know it in terms of graphs. Assuming the target year as 2014, the flood discharge of expectancy in return periods will be probability and flood discharge in terms of percentile as given below. Here, apart from only 50 years, so many return periods of different years have been calculated along with the discharge. Also, the 2.5 percentile and 97.5 percentile of discharge has been discussed here, which gives the probability of the rainfall. And also most likely trend in mean confidence level and return period for plots of MU have been associated in these plots. The same values have been plotted in terms of graph here. These are the values of annual mean discharge for different years, and an average plot has been calculated here with the help of MATLAB function. And coming to the results, the analysis of such floods by LPP3, nothing but Logpearson type 3, has a great significance in flood hydrology research. It gives the best fit probability curve. This is nothing but a best probability curve which has been calculated. Although the aim of research is a flood frequency analysis, time series graph of annual peak discharge for all the sites have been shown in the plots. In coming to estimation of discharges, a design period has been determined on the basis of observed maximum discharge or historic flood. Therefore, the continuous long and good quality of record of stream discharges is essential for more accurate appraisal of recurrence levels. Generally, annual mean data has been calculated for recurrently for analysis. Accordingly, peak flows have been estimated for different return periods such as 20 years, 40 years, 60 years, 200 years by using LP33 method. The estimation of discharges for different return periods has significance in flood geomorphology, flood hydrology, and hydraulic engineering. And it is also useful in finding the return period, where it has a great significance for safety of hydraulic structures. Therefore, an attempt has been made to find out the return period for annual mean peak discharge. With the help of this return period, one can design at what strength a hydraulic structure can be designed for. And finally, to conclude the topic, the LP3 analysis shows the estimated discharge for low recurrence levels, which is a closed observed peak discharge and return period of the mean annual flood. Therefore, based on the observations, it is said that LP3 distribution is the most suitable for flood frequency analysis of flood frequency distribution. Additionally, estimating the flood discharge with the help of return periods and return flows, you can get an idea of occurrence of floods quite early compared to the forecast. Though the forecasts are quite accurate, we can just get a brief and rough estimate from this method so that we can be safe in future. Also, we came to know that this type of discharge helps us in designing many hydraulic structures to its safety point. This is it for the application of LP3 analysis, and which is an advanced statistical method used in civil engineering in the field of hydrology and hydraulic structures. Thank you, sir. Thank you, sir.